Electronic devices all around us use digital logic to form decisions and make calculations. In this tutorial, we will talk about how to construct the most simple decision-making circuits. These circuits are known as logic gates. We will learn about the AND gate, the OR gate, and get a brief introduction to Boolean algebra. Imagine there is a light bulb in Amy and Brian's house. This light bulb is controlled with two light switches. The switches are either on or off all the time. To turn on this particular light bulb, both Amy and Brian need to flip their respective switches. The two switches act as two inputs, and the light bulb acts as a single output. Let's construct a table showing all the possible input switch combinations and their associated light bulb outputs. If both Amy and Brian have their switches off, the light bulb is off. If Amy has her switch off, but Brian has his switch on, the light bulb will still be off. Likewise, if Amy has her switch on, but Brian has his off, then the light bulb will be off. However, if both Amy and Brian have their switches on, the light bulb turns on. Did you notice how I used the word AND? The situation I just described is called an AND logic gate. The light bulb will be off all the time unless both Amy and Brian have their switches on. Here's the symbol we use when we want to draw an AND gate. Amy and Brian have a second light bulb in their house. This light bulb is also controlled with light switches. However, this light bulb turns on when either Amy or Brian turns their switch on. Again, we'll construct a table to show all possible inputs with their associated outputs. If both Amy and Brian have their switches off, then the light bulb is off. If Amy has her switch off, but Brian has his switch on, the light bulb will turn on. Likewise, if Amy has her switch on, but Brian has his off, the light bulb will also turn on. If both Amy and Brian have their switches on, the light bulb remains on. Notice I used the word OR this time. This situation describes an OR logic gate. The light bulb will be on if either Amy or Brian have their switch on. I want to point out that the light bulb will still be on even when both switches are on. Here is a symbol we use when we want to draw an OR gate. As you may have guessed, there aren't little Amy and Brians running around inside all your electronic devices. That is where transistors come into play. Transistors are like little light switches. When you apply an electric current, the switch is on. When there's no electric current, the switch is off. Two or more transistors can be arranged to form the logic gates we have discussed. Here are the two logic gates constructed using transistors. In 1854, an English mathematician named George Boole introduced a new algebraic system where the variables have values of either true or false. Little did he know a perfect application for his Boolean algebra would come into existence more than 100 years later in the form of digital logic circuits. In digital logic, there are several ways to express the values of true and false. The value of true can be expressed as the number 1, the word high, or even 5 volts when we're talking about electricity. The value of false can be expressed as the number 0, the word low, or 0 volts. We can also express the logic operations previously mentioned using Boolean algebra. The logic operation AND is most commonly expressed by writing the two variables next to each other with a dot between them. Once you get more comfortable with seeing this operation, the dot is often left out. The OR operation is expressed by writing two variables next to each other with a plus sign between them. I want to note that this plus sign does not mean addition. I know this seems confusing at first, but you will soon train yourself to think A and B when you see this expression, and you will read A or B when you see this expression. You now know how to express logic operations by either drawing them or writing them algebraically. Let's practice some simple examples. I want you to read these two equations out loud and then draw the correct logic gates. Pause the video here and try it on your own. When you see the first one, you should think Z equals E or F, and you would draw an OR gate with E and F as the two inputs and Z as the output. The second one reads Y equals C and D. Here is what you should have come up with. When the output of one logic gate is connected to the input of another logic gate, we call that a logic network. For example, in this logic network, the output of the OR gate becomes one of the inputs to the AND gate. Algebraically, we would write this as Z equals A or B ANDed with C. Notice how we put the parentheses around the result of the OR gate in order to distinguish it as an input to the AND gate. To finish this tutorial, you will try a couple examples on your own. Try to draw a logic diagram for this equation. Pause the video here. Here is what you should have come up with. Now try to write a boolean equation for the following diagram. Pause the video here. Your equation should look something like this.